Hello everybody. Welcome to Creating the Basic Adaptable Game Engine Library, Part 18, Game and Screen Class Code. In the previous video, we learned about the design ideas behind the game class and a related interface called screen. We learned about the different fields we'll need in the class. It's really extending what we did in JavaFX and making it reusable for our future games. And in this video, we're going to go ahead and write the code. So, first step, I'm going to go ahead and open up IntelliJ. All right. And first, let's maybe create the interface. So I'm going to right-click and make a new Java class. Well, technically an interface. This is going to be called Screen. And interfaces are great. They allow you to specify what the required functionality will be, but we don't have to implement it here. It's kind of like an abstract class almost. So really, every screen has to satisfy two methods. Right? So first, there's an abstract, let's say public void initialize. Right? In this method, we need to set up all the different game objects. And then we also have a public void update. Right? And in this method, this will run 60 times per second. That's really it. Let's go ahead and create a game class, and the game class will implement this interface. So, creating a new class. This class will be named Game. And hopefully this code will look somewhat familiar. It's really following what we did when we set up the JavaFX introduction classes. So this is going to be a public class called Game. It's going to be an abstract class because it's meant to be extended. And in addition to extending, this class needs to be extended, and it itself extends the application class, right, which is from JavaFX, so we'll import that. In addition, it's going to implement the screen interface. Wow, that's a lot of stuff going on there. So extends application and also implements screen. Now, typically, if I tried to implement a class or implement an interface, usually that would trigger an error because I haven't written the corresponding methods, in this case initialize and update. But this is an abstract class, so it falls to whatever class extends game to implement those two methods. All right, here we'll first create the basic elements we need. We're going to need a canvas on which to draw objects. We'll go ahead and add that import. All right, JavaFX canvas class. We also need a graphics context class. Just call that context. And there's the import statement for that. What else do we need? Well, we're going to need kind of a group that'll contain all the different entities, all the different sprites and other groups of sprites. So let's create a public group called group. And finally, for use by the methods setTitle and setWindowSize, which we're going to create later, we're going to want to store the stage, or reference to the stage the application class creates. So we're going to create a public stage called stage. Okay, and yes, we have to import this as well. Import class. There we go. JavaFX stage. Cool. Next step is to write that start method. Right? Every application must implement start. Public void start. And I'm very much going to follow the same pattern that we did in the previous video. This will be a stage. We'll call that main stage. All right, we'll set a default title here. Maybe we'll say main stage.setTitle game. And I don't want the user to resize this, right? We're going to have some kind of a fixed window size. So let's say main stage set resizable false. Good. Next, let's set up the pane, which we'll use to organize the contents. So pane root is a new pane. New pane. And of course I need to import that. Did I get imported? Yes, it did. Great. Now I can set up the scene because I know I'm using a pane to organize the contents of the scene. So this is a new scene which uses that pane. And hey, we need to import the scene class. Next, we want to connect the scene to the stage. So main stage dot set the scene to the main scene. And also is just kind of a nice little addition. I'm going to use something called size to scene. That way the stage will be exactly the same size as the scene it contains. Notice I didn't actually set the size of the scene here. This will make everything automatically resize itself, which will be nice. For the canvas, let's initialize that. That'll be a new canvas. I'll make it a square by default, but you can easily change that. For the context, we get that from the canvas element. So canvas.getGraphicsContext2D. Good, good. Root, we want to add the canvas to the root. Right, so within the pane, get the list of all the children and add it to that list. The other variable we set up a group object. We should initialize that. Group is a new group. And now, I'd like to go ahead and set up the animation timer. So animation timer, I'll call this game loop, equals a new animation timer. I need to implement something. First, I want to go ahead and import that class, animation timer. Next, this red squiggle is because, well, it's in like an interface and I need to implement a method. That method is called public void handle and takes in nanotime as an argument, which we're not really going to use. Now, here's an interesting issue. Within the handle method, I want to call the update function, and the update function belongs to this class. It belongs to the game class, since the game class implements screen. So we need to worry about scope issues here, right? The animation timer object does not have an update method. The update method belongs to this class in which this class finds itself. So just to clarify the update here, to clarify class containing the update method, right, normally I'd use the variable this to refer to the class. But if I said something like this.update, that's not going to work because animation timer does not contain an update method. Instead, I'm going to say there's a game object, and I'm going to set self equal to this. So then within the handle method, if I call the update function, now self refers to this variable, which is initialized to this, meaning the game class, not the animation timer class. And sometimes we have to be very careful with references. All right, so that's going to be used to update the game state. Update game state. What else do we need to do? Well, we learned when we were doing animations that we should clear the canvas. So let's do that. So again, you don't always need to use self, but I'd like to use it just to clarify that context does not belong to this inner class, but the outer class. So self.context, I'll set the fill color to maybe just like a gray color. I need to import that class. Import class color. That's in JavaFX. Then I'm going to go ahead and fill a rectangle. So self.context.fillRect, starting at 0, 0. And I might change, or you might change the size of the window later, so I can't do something like 512, 512. That might not be right. So instead, I'll say, well, the size of the rectangle is going to be canvas dot, or maybe I'll do self.canvas.getWidth. Let's move this up so it's more easily visible. And self.canvas.getHeight. Okay, so right here, we're just filling a rectangle, starting at the top left corner of the canvas, and with size equal to the size of the canvas. And once we've done that, now we can draw all the objects that we've stored in the group. So let's render all the game objects. That'll be self.group.draw self.context. Right, remember, a group has a draw method, and the group draws something by calling the draw method on all of its contents, whether they be subgroups or individual sprites, and they use the context to draw themselves. And we still do have to implement the draw method for the sprite objects, but we'll do that in the next video. Okay, when that's all done, well, we've set up our timer. I'm going to do things in a slightly different order than the JavaFX video. I'm going to go ahead and say mainStage.show. And then I want to go ahead and initialize. Right, set up call the initialize method. That sets up all our game objects. That's implemented by an extending class. And then we're going to start the game loop. Right, we don't want to start the game loop until the objects in the game have been initialized. Cool. Now, another thing that I'd like to do is write those helper methods, in case you want to change the title in the title bar or change the size of the window. But we need a reference to this stage in order to do that. That's why we set up a stage object, and so we'll set that value here as well. Right, in this case, we need a reference. A reference is required for the set methods that we're about to write. All right, that sounds pretty good. Now let's go ahead and just write these last two methods. These two aren't going to be too much. Public void set title. Well, we need a string, which is going to be the new title, to be displayed in the title bar. And that's stage.setTitle to that title. The other method we need is public void set window size. I mean, really it's set window size and canvas size, but that's a pretty long method name, so we'll just assume that's understood. And we'll add comments later on, which makes that very clear. So stage.setWidth to this new width, stage.setHeight to this new height, and then also the canvas. So canvas set width to this new width, and canvas set height to this new height. All right, I think that's all we're going to need for the game method. Right, things are starting to come along pretty well. Oh, lights went out. Lights go out sometimes because they're on a motion timer. So we have all the methods we need for this class. Right? We should probably write a test class just to make sure that this works. So in order to test this out, let's go ahead and right-click and make a new class. Let's call this test game. And test game is going to extend the game class. And already we see that this game isn't going to work unless we do some things, right? In particular, we need to implement two methods. We need to implement public void initialize. We need to actually write code in it. Well, we don't need to write code, but at the least we have to provide an empty method. And an update method. Now in theory, this game would compile as is. Let's go ahead and try out some of these methods. We won't draw graphics yet, but we can test what we have, and if we can test, we should test. Set title, we'll call this test game. Set window size. The default was 512 by 512 pixels. Let's make that a rectangle with a 4:3 aspect ratio. So set window size to be 800 pixels by 600 pixels. And finally, let's just do a system out println hello world. Hey, it's tradition. And we don't really need to put anything in the update method now. We just want to make sure that this class works. Let's go ahead and try running this new class test game. This goes according to plan. We should see a window appear. That window should be, it should have a gray background. The canvas is being cleared with gray. We can see that it has the size that we specified, and the title bar does say test game. So this is great. And just think about how nice this is going to be. Because of the framework, because of this library that we're setting up, we can really focus on game design considerations. Right? All we have to do is implement these two methods, initialize and update. Although we do have to go back to some of the library classes and add some more functionality from time to create more advanced games. But already, this is looking very efficient to use. In the next video, we're going to work on the sprite class so we can actually start drawing sprites in our game windows. But that's enough for this particular video. Thanks for watching.